Hey, welcome everybody. Hey, Josh.
Hey,
Good to
hi
see you
there.
again.
Hey, likewise.
Yeah. Welcome everybody that's joining us live on this Microsoft Reactor Learn Live series, where we are building and running intelligent applications on Azure Kubernetes Service. This is episode number 4, right? Yeah.
I believe
I have
so.
four
Yeah.
fingers. Yeah. Episode number 4. And this is the last episode, unfortunately. We've been having a lot of fun, but unfortunately, all fun things come to an end. But I'm really happy to be here with you, Josh. I think this is our first one together.
Yeah.
We've
Yeah.
kind of been
Usually,
flip-flopping back and forth, but yeah. What a way to close it out. For the folks that don't know me, my name is Paul Yu. I am a cloud native developer advocate at Microsoft. I do a lot of stuff around the Kubernetes ecosystem, more specifically around AKS, and I am joined by my wonderful teammate, Josh. Why don't you go ahead and introduce yourself?
absolutely. Well, first of all, thanks for having me on this, and I'm glad that we got to do this live stream again. We've kind of been missing each other. I hosted one, and then you hosted several other ones, so it's good to share the stage again with you. But my
Yeah.
name is Josh Duffney. I am on Paul's team, so I have very similar, if not the exact same title, so I won't repeat that. But I have a little bit of a different focus. A lot of times I do with this secure supply chain. And so I've been involved with a number of open source projects. But the single thread that kind of weaves together our team really is Azure Kubernetes Service. And so I'm excited to be here and to talk about the network security. I remember when we were doing preparation for this, it brought me back to, oh man, the beginning of my career. Probably it was 10 years ago that I wrote a post on Spiceworks where I was studying for my CCNA and I was doing on pen and paper doing subnetting calculations. And so it's cool to see that relic out there, and so excited to kind of bring back some of those memories and to have some good mental models to share with people around network security.
Yeah. Unlike you, Josh, I have bad memories of the CCNA.
Oh, I didn't say
I
they were fun. I didn't say that.
I
Uh,
I failed that thing badly. It's kind of what drove me into software development instead.
mhm.
Yeah, but awesome. Thanks for being here, and I'm pretty sure this is going to be a fun one. Um, the next thing we want to introduce Michael. You may have remembered Michael. He's been with us for episodes 1 as a moderator, and he was on episode 2 as we worked through workload identity and AKS and Azure OpenAI. So Michael is hanging out in the back, answering your questions, comments that come through. I believe we're streaming on Twitch and YouTube this time around. So feel free, if you have any questions or comments along the way, just go ahead and drop them into the chat. We want to make sure that the session is interactive as possible. Okay. And then just another quick shout out. We have Steve Morowski, who's on our team, also in the background, just kind of managing a couple things for us when it comes to working this stream. So appreciate everybody for being on and helping us. So let's just go ahead and dive right into it. So what are we going to be learning today? I guess we could step back just a little bit and just recap everything that we've done so far and seeing how today's Learn Live session will kind of hopefully tie it all together. So back in episode 1, when I was on with IO, we just deployed a store, a kind of like a fictitious pet supply store. And it was all built on microservices architecture, deployed to Azure Kubernetes Service. And we wanted to enhance our employee experience by literally bolting on AI and giving employees the ability to generate product descriptions with the help of OpenAI, in this case, Azure OpenAI. And so what we did was we just literally just bolted on that service. But there was a problem there, right? We were calling Azure OpenAI using an API key that was stuffed into an environment variable in one of our containers. Although that's totally doable, ideally we would want to secure that a little bit more. And then in episode 2, Josh and Michael walked us through how we would configure workload identity and have a completely passwordless approach to making those service calls between our AI service, and Azure OpenAI. From there, in week 3, we covered a whole suite of tools that can help us make our application a lot more resilient and scalable, right? We introduced Playwright, Microsoft Playwright, which is a service that enables full, complete end-to-end testing of your application. Then we also introduced Azure load testing to help with the scalability of our application. And then the fun toy at the end, which we didn't really get to dive too deeply into, but we totally have the lab content available for you, was Azure Chaos Studio, where we basically introduce chaos and we break things. And, hopefully that will help us exercise and make our applications a lot more resilient. Now, today, we're going to circle back to the security component of our application. But this time we're going to focus in on network security. And so what we're going to do is we're going to run with we're going to run with workload identity again to make sure we have that complete passwordless experience. But what we're also going to do is we're going to secure from the networking approach where only traffic from our virtual network that we're going to create can make calls to our Azure OpenAI service. So that way we're securing from 2 fronts, identity front and the network front. So with that, let's just go ahead and dive in. Oh, whoa, wait. There's one more thing. We've been using a service in Kubernetes of type load balancer, which gave us a public IP to our site. We're going to expose our application just a little bit differently today. And we're going to be exposing our application using the brand new Azure Application Gateway for Containers, which is a new service, which is currently in preview. And we're going to expose the app using the brand new Kubernetes Gateway API, which literally just went version 1.0 2 days ago. 2 days ago? Yeah, 2 days ago. So it'll be fun. It'll be fun. So with that, let's talk a little bit about Azure Virtual Networking, because that is a prerequisite, isn't it, Josh?
It is, absolutely. So I'll talk a little bit about on this side. So we take kind of for granted. I'm kind of very grateful for kind of my upbringing in technology because I worked on the help desk and then I worked as like a one-man shop and in like a small bank. And I actually had to go run around and plug in cables and connect different sites together and jump into a router or a switch and actually turn on and off the ports to be able to connect them. And we kind of take that for granted. I feel a little bit bad for people that grew up in this cloud area where everything is it's publicly connected. Everything is connected to everything. And we kind of forget that we don't always want that kind of connectivity. We don't want anybody on the internet to be able to access our different services or resources that we have in Azure. And that's where this virtual network comes into play, where throughout this demonstration or throughout this workshop, this live stream, what Paul's going to be doing is isolating through networking our OpenAI service and our Kubernetes cluster. And so what he'll be doing right now is currently the way it's set up is anybody. We're just calling a public endpoint that Azure provides us to OpenAI. And if anyone were to get our credentials, they could consume our service and hike up our bill. And that bill for these services it's not cheap. It's pretty expensive. Just like any service, really. And so we want to protect that more. And the easiest way is to protect it is just make it not accessible. And that's what we're going to do with the networking. So we're going to cut off public access to Azure OpenAI, the service that we're using to generate those descriptions in our pet store app. But we're going to have to allow some kind of access so we can still have our services running. And so that's why we're going to put a nice network boundary, a VNet, around the cluster. So that way the things inside the cluster can talk to the OpenAI. So that at a very, very high level is what we'll be doing throughout this live stream.
Okay, cool. So if this is me over here and I have a local copy of my AI service, I can't call that? Like, well,
yep,
it'll
you would
just
have
get denied,
to.
or
You would get denied. Yeah, it wouldn't be
I'll get denied.
accessible. Yep.
Okay, cool. So what will we need to set this up? So I see the VNet.
Mm-hmm.
we create the virtual network, and there's some requirements around that, right? We're going to need an address block.
We are. So
And
you're calling me back to my CCNA prep days here, Paul. Yes. So the address that you're going to need is, it uses CIDR notation, and that is
Mhm.
classless interdomain routing.
Yeah.
And that usually has two parts. It has a network address, and then it has a subnet mask. So the network, the IP address range, rather, that's the more appropriate term for it. That is the available space that you have to assign addresses. And that IP space is made up of two portions. You have your network portion, which identifies the network that you're going to be on. And so we'll see that in play as we give a network to our cluster and a network to OpenAI, that they can talk to one another. They're still inside the same overall IP space, but they're different
Mhm.
networks inside that. And then they would need some kind of a router in between. And then the latter part is the host portion, which just determines how many IPs in a network you can give. And so if you've ever looked at IP, I'm sure you've run across it. There are 4 different blocks, and each of those are 8 bits. And so if you do base 2 and you take 2 to the 8th power, you get 256. And so each of those can have 256 in them. Each block's incrementing up, so that'll give you your host bits. The interesting fact there is at the very beginning, address 0 is reserved for the network, and the very end address is reserved for broadcasts. And so you can't use those 2. So if you took 2 to the 8th power, you get 256, but the very first 0 is going to be reserved, and 256. So you don't assign
Yeah.
anything 256. Azure won't let
Yeah.
you. But I
Yeah.
learned some of those lessons the hard way, assigning IPs manually. So that's one thing that we'll get a little bit familiar with. You don't need to know a lot about it, but it is one of those things you just kind of copy and paste. And if you don't have a little bit of background, it'll get you in trouble.
Yeah.
And so
Yeah.
that's one of the
Yeah.
things that we'll be
And
diving into.
again, it's like making me shudder to think about my CCNA days. But let's actually look at it and implement it from a code perspective, actually from an Azure CLI perspective, and maybe it might give some of our audience a little bit more insight in how easy it is now in the cloud these days to carve this stuff out.
Mhm.
So let's just jump right into the demo. And I would say, if you have not already scanned that QR code that flashed, actually it was on the title page as well. If you scan that QR code, or if you head over to the link that I'm hoping is going to scroll on the bottom, there we go.
There it is.
If you head over to that URL there, it'll take you right here to our workshop material. And this is where you can literally deploy all these things. And, as with previous weeks, this is totally in a code along or a code with me fashion. So feel free, do all the steps that I'll be doing here, and follow along. There is one caveat though. To deploy this stuff into your Azure subscription, you do need access to Azure OpenAI. So if you haven't already accessed that, I can't remember the AKA link. I always, this is the way I get to it. I'll just do a search for OpenAI and AKS, and I will, hopefully it's the first link there that shows up in your search results. But what I like to do is I'll just come here, and there's a before you begin. And what you can do is you can just click on that link there. It'll take you to the form where you can request access to Azure OpenAI. And I'm hearing that the turnaround time on that is fairly quick. So hopefully within maybe a day, maybe less than a day, you'll gain access to it. So let's go ahead and do that. So let's start building this stuff. I don't have anything pre-provisioned today. We're just going to do everything from scratch.
If you watch any live streams of Paul, that's how he likes to roll. He likes to build everything from the ground up and just pray that it all works, which is fantastic. It makes it way more fun.
Yeah. The demo gods. I did make my sacrifice to the demo gods this morning. I emptied my recycle bin. So hopefully that works.
Well, I love what Hanselman says, where he says, like, you don't need to pray to the demo guys anymore. Anytime it fails, it's just an opportunity to learn live, which is kind of the title of this. So,
Hence the name. Yeah.
Hence the name.
Learn live. I love it. That was great. Okay. So what I'll do is I'm gonna copy this first command here, right here. And remember, with these labs, click on that button to prevent your, any mistypes or anything that weird that might occur. So just click that button to copy the text, and I'll flip over to my terminal. And you'll have to excuse me because I'm going to be flipping back and forth between my terminal and the instructions. So here I'm just creating a random character, and I'm creating a resource group with that random character. And I want that because some of my resources, they actually need to be globally unique within Azure. Okay. The thing that we're going to be doing, like I said, is going to be workload identity and then network security. So we're going to implement all this workload identity stuff, but hopefully at this point, it's like muscle memory and we can just breeze right through it. So let's go ahead and deploy this now.
And if you want to deep dive into the workload identity, the session, I think week 2 that Michael and I did, we went in depth of how that all works and how that's set up. So if these commands are kind of washing over you still, or you're just joining us for the first time in this 4th edition, make sure to go back to the second one, and Michael and I dive deep into the workload identity, what it does, how it works.
Yep. Okay, so the next command is we actually need to create the VNet. Okay. These parameters are pretty simple. We're going to give it a name, and then we're going to tell it where to drop it into our resource group. But what's this right here, Josh?
That's that cider, not apple cider, but the cider notation. So you got the
Not
IP
apple
address,
cider.
and you get the subnet mask there.
Okay.
And so the subnet mask is telling you how big the host bits are going to be. So how big there's going to be for networking. There's 8 bits reserved for the networking. So then there's going to be 8 more bits reserved for the host that you can divvy out. And we'll see that as we go on, where we slice this yet again to do, I think it's a 24 inside for just the cluster.
But yeah. So this becomes my network identifier, right? The 1021. Yep. Yeah. Okay.
And then the last two, the 0 and the 2 last zeros, can be incremented up for an address space. So you could do 10, 21, 1, and then anything in between 0 or 1 and 255 could be a valid host IP address. So
then I have all this space right here to play with, which is this will take me up to 255. So yeah, that's
you times those together, and there's your available host IPs. Yeah.
Got it.
I did this by hand because they didn't let me have a subnet calculator, and all that's just, it's gone. I have some blog posts that help me with it, but most people are going to use a subnet calculator these days to figure out the host bits. But
I use a subnet calculator.
Yeah, I would recommend it.
Yeah, I don't like to.
There should be, I think on your phone there should be an option for IP subnet calculator instead of just normal calculator.
Right.
For us IT people, yeah.
I think that's an app that you can write in.
I bet there's an app out there. Yeah.
Yeah, I'm gonna head over to the to my app store and look for that. Okay, so I'm creating the VNet now. What is this? What is subnet? Yeah, so VNet subnet create, and this again is the CIDR thing again. So this is basically saying inside of this network here, I'm going to create a subset or a subnet of this overall virtual network, right? And so my subnet, this becomes the address space that I get to play with for my subnet. So 10.21.0, right? The next thing that we also want to do here is, and this is especially important when you configure network security between a particular subnet and an Azure resource. The one thing, and it's a bit of Azure magic that you'll just need to be aware of, is this whole concept of service endpoints. Okay. Service endpoints, there's a couple different things there, right? Josh, there's service endpoints and then there's private endpoints. Pop quiz, do you know what the difference in when you would use either or?
I can speculate. One pertains to like a service, and it's going to be able to, what I'm imagining it's doing is it's creating an endpoint that's able to traverse the different networks right? So
Mm-hmm.
this service is being given a path by a router, some kind of a default.
Yeah.
Typically, it's a default gateway that you can configure on a host, so that way it can communicate between. Because when you've divided that network space, it now cannot reach anything, even though it's part of the /16. It can't
Mm-hmm.
reach anything outside of its names or its IP block or its subnet, and it needs some kind of a route. And I would imagine what that magic is doing is it's creating that route in the back. The service one, I would imagine, would be doing that for a particular service, and then the private one, which would that would give you the ability to do some kind of a resource between, but it's not a service. It's a resource that's defined that you have more control of deciding what those endpoints are.
Yeah, yeah. And that's definitely right. So this service endpoint basically changes the way your source IPs are going to be attached in that network request that gets made. If you do not have a service endpoint attached to your subnet, anything that goes out to the I guess other Azure services like Azure, PaaS services or platform as a service services, the source IP is typically just a public IP, right? In order to basically, what we're doing is we're creating like a firewall almost. And when you do this, it basically assigns the source IP of your outgoing traffic to be an IP address from your virtual network space. So this enables, on the other side, the receiving end, that service that's going to be receiving that request, in this case, Azure OpenAI, is basically going to say, oh, where's this traffic coming from? Oh, from this virtual network. Okay, cool. Let me let it through. So this gives it that identifier. And then when it comes to Azure networking, you do have this thing called service endpoints and then another thing called private endpoints. As a general rule of thumb, if all your services are in Azure and you want resources in your virtual network to communicate with other Azure resources, all you need is a service endpoint. If you have some sort of hybrid connectivity, or if you want to access Azure resources from other locations, even outside of Azure, let's say on-prem or wherever, that's when you would use a private endpoint. Okay, but general rule of thumb, if it's all in Azure, just use service endpoints where they're supported. Okay, so we created the virtual network and the subnet. Now it's time to create the AKS cluster. Now, this should be very, very familiar. We've done this before. We've done this before. This looks familiar, actually. Yeah. Enabling the OIDC issuer and the workload identity, right? What's a little bit different here is this right here. So here we are saying we're going to use a network plugin of Azure. This is Azure CNI. And we're telling it to deploy into our subnet. Okay. So let's do that. And
these are all things that I had to worry about when I was spinning up a new site, or we were going to do a new Active Directory domain and we need network segmentation. I'd have to know and calculate these things and make sure that they weren't overlapping. We kind of just take that for granted because you take those off there and Azure is just going to figure it out for you.
Yeah. Yeah, exactly. So this takes a little while. Let's just talk about network plugins a little bit, because there are some things that you should be aware of. So we never really used network plugin, or we never really cared for it in our previous deployments. We just used the default. That default is KubeNet. And KubeNet is like a fairly simple network plugin that you can use for your AKS cluster. It's generally used for like smaller deployments. So if you have like 400 or less nodes in your node pool, and in this case, we are definitely lower than that threshold, KubeNet is just fine. There is some sort of like internal networking that's going on when you use the KubeNet, because only nodes in your cluster actually get the IP address from a virtual network that Azure manages for you. everything inside the cluster at that point is all private IP addressing, and it's completely different, completely segmented off from your actual virtual network. Now, there are some things inside of Kubernetes that is able to do like network address translations to enable connectivity. But again, it's all kind of hidden in the background. Kubernetes takes care of all that networking for you. When you use Azure CNI, what this does is it places your nodes into the subnet that we've carved out. But not only that, it actually gives every single pod in your Kubernetes cluster an IP address from your subnet space, right? And so the concern there is you have to do some planning, right? This is where carving out your virtual network, carving out the right size subnet is going to be very important, because again, each pod takes up one of those IP addresses, and you could run into the issue where you run out of IP addresses. So planning is very important there. Now, I know it sounds kind of like a downside, but it's really not. As long as you do your planning, you get a lot more benefits around that. And a lot of the benefits are including things like this, doing things like this, like service endpoints, connecting to other Azure resources and creating that firewall, right? And also we'll see later on in the workshop that our application gateway actually requires Azure CNI as well. Okay, so let's see how this is doing. Gotta love live AKS provisioning. This usually takes about 5 minutes, so we'll just wait for it to deploy. I would say there is, there's actually a blog post that came out right here. This blog post, written by Sahi Ariel, was actually published yesterday. Look at that, right on time. You must have known that we were doing this live stream. But it's a pretty well written document on how to choose the right network plugin for your AKS cluster, and it even includes a flowchart, which I love flowcharts, right? And so this talks about all the things that I just mentioned, and so I would recommend that you go ahead and read through that. Hopefully, I'm pretty sure somebody will pop it into the chat at some point. Yeah, I see it there. Somebody's on it. Thank you. But yeah, check this out. It talks about all the different networking plugins that you can enable on your AKS cluster. So really good read. And I love visuals, so the flowchart is amazing. All right, there we go. Our AKS cluster is created. Now, what do we need to do? We can breeze through this stuff now because we're all pros at it, right, Josh? Azure managed identity and federate it with our cluster.
Yeah, and again, if anybody wants to dive deeper into that and slow that down, we did a whole, probably close to an hour segment on that in week 2.
Yeah. So we'll create the managed identity. We will grab the OIDC issuer URL. And then here's the magic. We create the federated credential. And that federated credential needs to have the issuer URL, the OIDC issuer URL, and then it needs to have the proper subject. So this needs to match what you are doing, what you're doing from the Kubernetes side, right? So service count, the namespace, all that stuff has to match up. So
that's a piece that connects the cluster to Azure to be able to exchange the tokens and authenticate using managed identity.
That is absolutely correct. And hey, look at that. This is very important. Cool. The next thing I need to do is create the Azure OpenAI service. Now, one bit of gotcha here is if you are going to use Azure AD, or excuse me, I always get caught, Microsoft Entra ID Workload Identity. That's a mouthful. You have to make sure that you enable the custom domain on your Azure OpenAI service. Otherwise, the authentication just won't work. So we'll give that a minute or two to create. It's really quick to create now. So once the cognitive services account is created, then we'll have to assign that. We'll have to assign that new managed identity we created read access to the AOAI account, right? So go ahead and do that. And AOAI, just my shorthand. I love acronyms for everything. So that's Azure OpenAI. So we'll give it the ability to call our endpoints. And then, yeah, we might as well just grab or allow ourselves read access as well. And then here's a cool thing here. We're going to need a model. So we'll do that. And yeah, I'm just breezing through this. And again, just feel free to check back on the recordings for the slowed down version. Okay, so here is where we're going to test a few things around networking, and I'll show you from the Azure portal as well. If I were to grab this command, I am actually going to look at the network ACLs, or the network access controls, right? Access control list. So let's go take a look at that. Okay. I don't have enough capacity. Yeah, that can happen. So let me do that. Because I have a few other deployments in probably the same region. So that can happen. So I'm
What's
gonna
the capacity print? What's that 60 do?
Yeah, so this is basically tokens. It's actually the size of the request token that's going to come through in your chat. So the larger the capacity that you have, the more requests per minute you can also have, right? So this is basically increasing the window size and the amount of tokens that can be sent to your Azure OpenAI account. And then that ultimately equates to RPMs, or requests per minute. So
okay, and that can change per deployment, because inside an OpenAI account, you can have multiple models, and those models can have different capacity or ability to handle larger requests.
Yeah, exactly. Awesome. So I cut it. I cut it in half, which is okay, because I'm not going to hammer this service. It's probably only going to be me calling into it. But yeah, you can. There are models with increased capacity or tokens that you can bump up to. I think it can go up to like 300 or something for certain regions. So do take a look at the documentation and the region that you're in, because the models and the model versions really play into how large of a capacity you can deploy there. Okay, so I got the model deployment. Cool. Now, what I want to do is check the network ACLs. So I'm just doing a AZ Cognitive Services account show command, and I'm pulling out the network ACLs, and you can see that it's set to null. What I'm going to do here is this: AZ Cognitive Services account network rule add, and look what I'm adding. So I'm adding the subnet ID. I'm basically going to say deny all traffic from anywhere else except for traffic that is coming from this subnet. Okay.
So currently, because it's empty, it's going to accept everything. And as soon as you add a rule, it's going to limit it to just what you've added.
Yeah. So let me kick off that command real quick, and I will show you in the Azure portal if I'm quick enough. Bum, 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 bum. What? Yeah, you see all my resource groups. There we go. Azure OpenAI. And if you go down here to networking, it was too fast. This is the default, all networks. Okay, so this was like private or public access to your endpoint if they had your endpoint address or FQDN. What we did with that command is basically say only allow access from selected networks. And guess what? We only allow access from the subnet. There's additional firewall things that you can do. So like if I wanted to call Azure OpenAI from my IP address, I could do that. And I probably shouldn't be showing this IP address, but hey, you know what? But yeah, this is basically like firewalling your Azure OpenAI account. Okay. So now, same deal. If I just go and run this command again and show the network ACLs one more time, you can see that the default action is now set to deny. And the only thing that's being allowed is from this particular subnet. Okay. So that's it. That's basically all you have to do to secure access.
It's not too bad.
That's, yeah, not too bad at all.
Really just a couple parameters difference from the previous weeks where we didn't add the network segmentation.
Yeah. Yeah. It literally is just creating the virtual network, creating the subnet, and then the network ACLs for that. Oh, and then deploying the AKS cluster into the subnet. But yeah, that's just literally just another parameter.
Mm-hmm.
Okay. So we're done here, Josh. I think we could wrap it up. No, I'm just kidding. We got to test this stuff, right? We always got to test it. In the lab, I did include instructions for you to test locally. So, and I'm not going to do that, but feel free if you're doing this at home, do it on your own time, watching the recording, go ahead and clone this repo, drop into the AI service directory, do the Python commands. And if you don't have Python, no worries. There's a dev container in this repo, so you can just spin it all up there. And export all of your Azure OpenAI or access the configuration to talk to Azure OpenAI, and then run the app locally. When you run that app locally, remember the default action is set to deny. And what happens when you set it to deny? You're going to get this error. And it's basically going to say, OpenAI failed to complete the chat. And it's going to say right here, due to firewall rules. Okay. So that kind of confirms that nobody can talk to your Azure OpenAI service unless that call is being made from the subnet that we allowed. Okay. So we'll just skip that part and we'll just go ahead and test it right on AKS because I trust that it's going to work. So what do we need again, Josh? We need to configure some more stuff, right? We need to
probably the workload identity, I'd imagine.
Yes, we need to tie off the rest of that workload identity. And when we configure workload identity from our actual workload, we need the client ID of the managed identity, and we need the Azure OpenAI endpoint, which is that URL that we want to call. So I'll go ahead and grab those. So do that, run that command. Then I'll grab that next command because we never connected to our AKS cluster yet. So head in, connect to the cluster. Okay, so I'm connected, and I can say get PO A or -A, capital A. It's basically saying, give me all the pods and all the namespaces. I can do dev. There's no pods in my dev namespace, which is ultimately where I'm going to deploy this stuff. So now that I'm connected to my cluster, we're going to deploy the app, but we're going to deploy the app in a little bit different way today. All the way up until now, we've been using just raw Kubernetes manifests. We've been using kubectl apply commands to apply those manifests. We're manipulating the manifest, which I personally get tired of doing over time. I don't know about you, Josh, but sometimes I like an easier way to deploy. So guess what? We are introducing another tool.
Yet another tool for the Kubernetes ecosystem.
Oh, yeah. It's endless.
Oh, yeah.
There's tools on top of tools on top of tools. Anyhow, we're going to use Helm. Helm is a package manager for Kubernetes. Actually, we used Helm in last week's episode as well when we installed the Chaos mesh into our cluster. So hopefully it isn't too new to everybody. If you don't have Helm, head over to their website. It's a really easy URL, just helm.sh. I mean, I don't even have to Google it, or Bing search it, I should say. But go ahead and install that tool, and we can actually run this command that will deploy our Helm chart. So I actually published a Helm chart into my own personal GitHub repo. And because GitHub Container Registry, it is OCI compliant. And I know you've done a lot of work around OCI and OCI compliance, Josh. I can actually host my Helm package over there, which is really cool. So what we'll do is I will deploy from this package, give it a version number, give it a namespace that I want it to deploy into. I don't have the namespace, so I'm telling Helm to create that namespace for me. And check this out. Helm is like a templating engine. And inside of my Helm chart, that's what they call these packages or the definitions. Inside my Helm chart, I have some conditional logic in there that'll basically create the AI service if I tell it to. And over here, I'm saying AI service.create equals true. I'm passing it my information because remember, we're kind of like hand editing these manifest files up until this point. And so now I'm just literally setting them as variables. And so I have a AOAI endpoint that I'm passing in, which I pulled, and then the client ID. Okay. So let's go ahead and test the demo gods one more time. I'm like really pushing my luck here. So there we go. That's the command. It's going to pull from my GitHub container registry. And within, there we go, it's deployed. So now if I do a get PO in my dev namespace, and if I tack on the -w to just watch it, I can kind of see what it's doing. I'll drop this down just a little bit just to kind of see it there. So storefront's running, RabbitMQ is running. Cool. A lot of this stuff is coming online. So it does take a few minutes for that. Okay. Everything looks on the up and up so far. AI service, product service is running, make line is running. Okay, they're all coming up. Oh, order service. Oh, virtual worker errored out. That's okay. I'm not worried about virtual worker. That's just a it's just a process that I have running in the background to kind of simulate load to my application. So I'm okay if that errors out. What I don't want to error out are some of these other things. So let's just bail out of this command. Take out the watch. Dum, dum, dum. So it looks like the only thing we're waiting on is the AI service. So give that like another second or two. And we'll just wait.
What are some commands you can use to kind of check on that? Can you describe it, or can you log it, or kind of depends on the status of the pod? But
Yeah. So what you can do is remember there's pods and there's deployments. So you can actually do a describe deploy in my dev namespace, the AI service, and you can see that it's been scheduled, right? So it's been set to run one replica. So from a deployment perspective, everything seems good. And so the next thing you want to do is you want to start to inspect pods. So you can do get PO dev. Oh, and it's, of course, it's running now. But if you wanted to see what's going on with this particular pod, what you can do is you can do two things. You can do logs, which I love to do. Oh, no, I didn't want to do that. There we go. So remember K, I alias my kubectl to just use K because I'm lazy at typing. So I'm basically saying kubectl logs in my dev namespace and this one particular pod. So if I do that, you can see that there's a lot of health endpoints or health checks that's going on to ensure it's on the up and up and it's ready to accept traffic. And you can see that it's been set to authenticate to Azure OpenAI using workload identity. So we are good. So I'll just clear out of that. Now, what are we going to do? We're going to test it, okay? And there's this other command here that we haven't done previously because we were getting public IPs on these services. But if I do a get service in the dev namespace, let me just drop this down a little bit. Okay. You can see that both store admin and storefront. Now remember, these are my UI applications. The service type is now cluster IP, which means I can only access these services from inside of my cluster. There is no ingress or entry point into these applications. In the past, we were using load balancer. When you use load balancer on AKS, it actually provisions in Azure Load Balancer. You get a public IP, and we're able to access that pretty easily. Not this time. And so how do you access these services? You can do what I wanted to do. I'll go ahead and copy that. You can do a port forward. So basically creating a little tunnel between service on AKS and your local machine. So I'll do a kubectl port forward to the store admin site because we want to test the AI capability, right? And we'll go ahead and do that. And so once I do that, I can literally access that site using localhost 8081. Here we go. That's there. And I can add a product and woohoo, it's up and running. So what was it? Tug rope.
gotta put Bear's tug rope.
Bear. Oh yeah. Oh yeah. Shout out to Bear. Steve got a new dog named Bear. So Bear's tug rope. Hopefully Bear doesn't break it. Hey, look at that. Love it. There you go. We have a new product for Bear. So Steve, if you're online, you can go ahead and order that product.
Description coming soon.
Yeah, description. Yeah, no,
Or
the
image
picture's coming
soon.
soon.
That's what I meant. Yeah, image coming soon.
Yeah. So if I did a K-logs again, you can see, hey, look at that. So there, we just validated that, well, we didn't validate that we couldn't access it, but trust me, you can access it. You can only access it from inside of the AKS cluster. And if you don't believe me, run it locally and test it out for me. All right. So,
well, that kind of leaves a problem though. If there's no way for anybody to access that outside in the public web. So we've locked everything down. Everything's in networks. That's all good and secure, but now no one's able to get to my application, especially the pieces that I want them to. It's a store where I want people to come and buy stuff from, hypothetically speaking.
Yeah.
They need access to that. So how do we address that concern? I'm not going to just forward ports and then have people log into my laptop to be able to see the service.
Yep. This is where this new service that's in preview comes into play, right? Azure Application Gateway for Containers. And Azure Application Gateway, that name might ring a bell. You might have heard, if you've worked in AKS for some time, you may have heard of the Application Gateway Ingress Controller, which was an Azure implementation of Ingress, which actually talked to the Azure Application Gateway Service itself. And this new thing, and I'll just call it AGC, Application Gateway for Containers, is an evolution of AGIC, right? So this is Azure's latest layer 7 load balancing solution, and it's been kind of overhauled and revamped and rebuilt from the ground up to give you a more, streamlined, more performant experience, especially when it comes to Kubernetes and understanding how pods are totally ephemeral. They go up and down, and it's going to give you a way more performant, entry point to your pods, while also taking advantage of Azure PaaS services, right? And so this layer 7 load balancer actually supports a lot of cool features, including backend mutual TLS between services, traffic splitting, weighted round robin, URL header based, or even query string based routing. And the one thing that I find super exciting about this new offering is that it actually supports the Kubernetes Gateway API, which, as I mentioned earlier, it went GA with version 1.0 just a few days ago. Why is this exciting? Well, if you've done a little bit of Kubernetes in the past, and if you've worked with Ingress, the Kubernetes Ingress resource, you may have gone through some pains when it comes to implementing a lot of this traffic routing, traffic shaping type stuff, right? Because all that stuff used to be done in annotations, and almost every single Ingress provider had their own annotations. So you had to go and look up their docs and how to do particular things. Here with the Gateway API, you're getting a more streamlined, more centralized, more standard approach to implementing some of your gateways and HTTP routing. Okay, let's talk a little bit about some of the components that come with Azure Application Gateway for Containers, or AGC. And basically, the way it works is like this: you get a controller. That controller is actually running in the Kubernetes cluster, and you have this AGC resource that's outside of the cluster, right? And that thing actually talks to Azure Resource Manager and this particular resource, right? So that it can actually help you manage your resource inside of Kubernetes using Kubernetes manifest, but have it also talk back up to the actual resource outside of Kubernetes, and then make those routing changes, right? The front ends and the associations and some of the routing rules for you on your behalf, so that it can load balance between your pods. Okay. So yeah, that's the thing. We have to install that one ALB controller. So let's go ahead and do that. So what we'll do is, and I've outlined kind of the steps that you need right now. It's going to take a little bit to implement, like a few Azure CLI commands, but a lot of this stuff should be familiar. Okay, and I'll tell you why it's going to be a little bit familiar. Here's a quick diagram of how we can now work with this particular resource. So the gateway class is the ALB controller, or the AGC on the Azure side. All we need to do from the inside the cluster is create a gateway, and then we can create our routes. Okay. So what you need to do here is, because this stuff is in preview, you might not have some of these providers actually registered or deployed into your subscription. So go ahead and register those providers. It can take a little bit of time to do that. And then also add the Azure CLI extension for ALB, or Azure Load Balancer. Okay. When we want to install the ALB controller, remember the ALB controller is inside the cluster, and it's going to work with services that are outside of it, services that are in Azure. And guess what? We're using workload identity again. And so, like I said before, this stuff is probably should come like second nature to us now. And so it's like, okay, oh, we're creating an identity again. Oh, we're grabbing that principal ID again.
Well,
And we're
the
probably
common
grabbing
pattern
that
that
principal ID. What was that?
Oh, so the common pattern that I'm seeing is we're using workload identity to establish some kind of an operator or something that's running on the cluster that's able to manipulate Azure for us. So that way there
Mhm.
isn't something outside of the cluster coming in and trying to do something. It's all kind of
Exactly.
happening in the cluster and managing the resources out
Right.
in the cloud
Right.
environment.
Yeah. And that's a great way to put it. And for me, it's especially cool because you're literally using Kubernetes-centric resources, like the service account, as long as it's federated, right? Um, to grant it permission to do things on your behalf in your cluster. And you can totally scope it down to as low as you need it to be, right? Because with that federated credential here, you're really scoping it down. So like if there's another service account that's trying to use this service account, token, or if your pod has your namespace is different, right here we're using Azure ALB system. So if your pod is trying to use the service account and it's not coming from that particular namespace, it's not going to get access. So you can have fine-grained control when it comes to Azure managed identities and federated credentials. So I can't remember what okay, role assignment. That's what I did. Okay, so here we go. We're actually going to deploy the controller now. And look at that. Guess what? There's another Helm install command that we need to run. So we'll go ahead and do this. Install the ALB controller. Okay, sweet. Congratulations. I love it when I see messages like that. Makes me feel like I did something really good. Okay. The controller is deployed. Now we need to actually deploy the ALB, which is the Azure Load Balancer. Okay. This is that service that's going to sit outside. Actually, no, this is a custom resource that's going to be inside the cluster. So, but we need to tell it how and where to deploy our resources. Okay. And so here we can see that we are carving out a new subnet. Look at this. We're going to bump our network. So remember, the subnet for our AKS was 10.21.0. And so the address for this new subnet for the ALB is 10.21.1. Okay, but we're still using the same CIDR of a /24. So let's go ahead and do this.
Pop quiz. How many hosts can you have?
Oh, 255,
Yep.
54, 53. What do you think? Because
I think
there's a couple that's reserved, right?
it depends on how many you're reserving for. Typically just the first and last. So 55, you can go up to that.
I believe Azure is a little unique in that it also takes the second IP as well, or it takes like the first 3 or 4. I might be mistaken, but yeah, it takes the first few, and that's specific to Azure networking.
Good to know.
Yeah. One thing very special about this particular subnet that we're creating here is that we need to delegate it to this namespace. And what does that mean, delegation? Basically, we want our ALB, the Azure Load Balancer, to be able to connect or assign IP addresses from within this subnet. And so we need to delegate permission to this namespace so that Azure can join devices on our behalf in that subnet. And when you do this sort of delegation, number one, you can't have anything else in that subnet. And number two, I think a /24 is the minimum subnet that you can actually use. So 24 is a good number. So, and you can see here that we've also granted role assignments so that it can actually do that sort of work on our behalf. So it's going to need a app gateway for containers configuration manager role and the network contributor role. Okay. So once all that is in place, at this point, the Azure stuff is all configured. We have the controller installed. We have the managed identity deployed with the federated credential so that when the controller is running using that identity, it can make changes on our behalf. So we're good there. Now, at this point, we're just deploying a custom resource. And this custom resource is Azure Load Balancer. And we're basically going to give it a name and that namespace, remember, because that namespace was kind of lines up with what we created in the federated credential. And we're telling the Azure Load Balancer, we're saying, hey, Azure Load Balancer, you can work with this subnet and you can join devices in this particular.
So just to make sure I understand that namespace, if that was different than that was passed into the federated credential, that mismatch is gonna break all the authentication. It's not going to be able to manipulate anything in Azure.
Yep, because when authentication happens,
it needs that. Yeah,
the pod is going to pass that token up to Azure AD, and Azure AD is going to be like, I don't know who you are. You know, you didn't federate that namespace with me, so no token for you. So created the Azure Load Balancer. The next thing we need to do is create the gateway. And if I go back up to the drawing and excuse my scrolling, just think of it like this. Think of the Azure Load Balancer as being the gateway class. So it's a custom thing. In our case, it's based on the controller and the application load balancer. The next thing we need to do is we need to provide a gateway. And remember, a gateway is just the entry point into your application, right? So this is going to allow that north-south access. So we create the gateway, and then we can configure a route. So let's go back to gateway. And so what I'll do here is I will deploy the gateway. It's going to look for this particular gateway class, which is ALB, and I'm going to give it a name. And I know I talked about annotations, but there's just 2 annotations we need to make here. We need to make these annotations so that this gateway knows to use our application load balancer as its gateway. So I'll go ahead and run this command. And our gateway should be provisioning at this point. And do note that it can take a few minutes to deploy. And so what we'll do is we can watch the gateway. So store admin gateway. I think there was a little bit of a, I need to fix this instruction. I'll fix this as soon as I am done with this live stream. But this right here, this needs to line up with the actual name, which is AKS Store Demo Gateway. So surprised I didn't catch that earlier. But let's do this. That's not the name of our gateway. AKS Store Demo Gateway. Okay, so you can see that it's waiting for the controller, and eventually it will converge. And if I do this, yeah. Once it does converge, what I'm expecting is this address, excuse me, to be populated with a FQDN, or a fully qualified domain name. So we'll just have to be a little patient.
Do you mind if we recap the resources so far on the cluster and like how they're working? Because it's not fitting in my brain quite well. So there's we just did our gateway, and then what's that reconciling with? What's that? Is that another resource inside the cluster, and then that's going to reach out to Azure?
Yeah.
Like, how is that all? Do you mind walking through that a little bit deeper?
Yeah. So
or again,
the controller is what we deployed into our cluster. The controller actually enables a new custom resource. And that custom resource is application load balancer, right? So once we deploy the application load balancer, that is now a resource outside of Kubernetes that we are going to kind of point at to do our traffic routing. When we actually deployed the gateway actually pointed and said, "Hey, here's, I'm this new gateway, and I'm using this particular gateway class. So it is now relying on this gateway class to go provision ultimately on the back end is going to be a front end and associations. And once those things are associated, what it's going to do is it's actually going to write back to the gateway the FQ. And I am drawing with my mouse, and I am terrible at it.
Well, it's still not legible. Okay, so then that's going to give it. It's basically.
I'm a lefty drawing with my right hand.
Oh, I didn't know with him. Let's see here. Okay. So the gateway sitting on the cluster is where the pods are going to go to. Like, oh, this is how I get outside of the cluster to communicate, and then that gateway is also going to handle all the routes. But then essentially, then that gateway reaches out into that resource that was provisioned in Azure, and that's what's just like making the public calls be able to get in. That's the ingress now.
Right. Okay. So if I'm drawing a laptop, that looks like a laptop, right?
Yeah. Pizza box or a laptop? One of these two.
All right, pizza box. I'll give you that. So when you actually come in and you want to access the site, it actually will flow to the gateway and then come down to your HTTP route. And then the HTTP route will know, hey, I know store admin. Store. Oof. And I'm doing this live. This is terrible. Anyhow, the HTTP route will know to route to your store admin service. Okay.
It's making more sense.
Yeah.
Appreciate it.
And you can configure as many HTTP routes as you need. So, and they can all flow through the same gateway as well. And so what this does, and the cool thing about Gateway API is that you can start to segment off different roles and responsibilities, right? So, the cluster operator here can actually just provision, they just do the provisioning of the gateway. And then you can have one team, let's say you have a team that's manning the store admin. Well, they can write their own routes and route to their services. Let's say you have a a team just for storefront, so they can configure their own routes and then their own services. So it's a pretty neat way to kind of decouple a lot of this stuff, because in the past it was just all single ingress manifests, all handled through annotations. So
Where do the like kind of the settings? You said there's like the layer 7 where you can do the traffic splitting and you can do
mhm.
routes on that.
Yeah,
Is that right there at that IP route? You're defining those settings there.
that's all. It's all done right
Oh,
here.
that's pretty cool. So that's even closer to the application instead of up in some
Yeah,
nebulous load balancer.
yeah,
Okay, very cool.
yeah, yeah. All right, let's see. How are we? Woohoo! There we go. Application gateway for containers has been successfully updated. So it does take a few minutes. If I do this, look at that. I have now this lovely FQDN that was automatically generated for me. And so now what I can do is I have my gateway. I need to do the route. So if I scroll down here, I can actually run this command and grab that FQDN. And that was a bad copy. Or was it a bad paste? I don't know. Here we go. And if I echo FQDN just to make sure, cool, that looks
So that's
good.
now your new public endpoint.
Yeah,
Yeah.
yeah. And this is just a randomly generated FQDN that comes with your gateway. You can use this, you can totally use this as is. Or you can, obviously we don't use these weird, I should say weird. We don't use these unique FQDNs. We'll use our own custom host names. And so in your HTTP route, you can actually configure your own custom domain. Like I purchased a domain, and if I wanted to, I can just drop it into this list of host names. So if like my host name is like shop.aksrocks or something like that, I can just drop it in here. And then at my DNS provider, just configure a CNAME to the FQDN, and it should all
Got
work
it.
like magic.
I just got a couple
So
of emails the other day that several of my failed project ideas domains are expiring. It's kind of relieving. It's kind of relieving to let them expire. I'm like, oh, I don't need to do that thing.
yeah, I shedded a lot of different domain names myself that I was like playing around with. So what does this HTTP route look like? Number one, we need to give it a name. Okay. And then number two, we need to point to the to that gateway, right? So this kind of creates that linkage. And then we give it a host name. And again, this could be a custom host name, but we'll just use the FQDN here. And then we need to tell it where to route to. And I don't have any fancy routing rules here. It's just going to go straight to my store admin. But feel free to take a look at the docs. It's all in there where you can try it all out. So I'll go ahead and apply that.
Is this all stuff that say there's a fifth week at some point, right? Where we're building on top of this. These are all things that we could actually put into that Helm chart now, assuming the infrastructure is there and pass in these
Absolutely.
values. And so right now you're just
Yes.
kind of building on top of the app that's already been deployed, but
Yeah.
we could kind of bundle all of it, assuming the underlying infrastructure is there.
That's correct.
Okay.
And I'm intentionally doing kubectl apply here because we want to see the manifest, right? Like we've been
Not
looking at
just
the
a
store
abstracted
manifest.
parameter. Yeah.
Yeah,
Well, because
yeah,
if we were to put this in the help chart, really all you need to pass in for this whole block is the FQDN.
Or even, yeah, or a custom domain, right? So,
Oh, yeah, true. Very
yeah.
true.
Yep. Okay, so that's it. The actual HTTP routing is like instantaneous, so we don't need to wait on that. So if I literally click on this, drum roll, please, boom, there we go. So now anybody with this URL can come to our website and order actually not order because this is not the storefront, right? This is the store admin. So you can add a product or edit a product. Yeah, we'll change the name.
It
Oh,
probably has
that
to
would
be a
be
little bit
awesome.
more money. If it's
Oh yeah.
meant to
Yeah.
fend off a bear
Yeah.
and last any length of
I'm
time.
not sure if Steve would appreciate that though. He would probably want it to be a little cheaper.
Well, I suppose that's very true.
Yeah.
It's got a box
So
of them laying around somewhere.
yeah. So that's pretty much it. I would say you might be wondering, okay, this is an ingress point, and typically application gateway on Azure came with what's called a WAF, or a web application firewall. And that's probably the number one reason why I wanted to show everybody this brand new service, which is currently in preview. Um, and it's because of the fact that, yes, the WAF is coming. It's not implemented yet, but from what I'm told, and you can, feel free to, I'm going to drop his name, but Jack Stromberg is the PM for this particular feature. He is super kind and helpful. If you have any questions related to this particular service, he's always happy to answer questions around that. But yeah, I was told that the WAF capabilities is going to be a fast follow within this preview period. And so that becomes another layer of security that you can tack onto your particular solution. And it can help you protect things from like your OWASP top 10, top 10 vulnerabilities when it comes to web applications, and even protect you from malicious bots and all that stuff. So, and they're all Microsoft managed rule sets. So that's going to be pretty neat. So hopefully.
Well, I tell you what, Paul, this whole session has been a trip down memory lane for me, because as you're mentioning all these things, I'm thinking back to my one-man shop IT person days, and I'm like, oh, well, like the router, that was something I had to stack in the rack, and the switch was another thing I had to physically mount into the rack. And then you're talking about a firewall and the WAF, like those are different appliances that I hooked in top, like on top of my routers. And so I'm just
Yeah,
like, I have all those mental models, and now it's just a couple clicks. It's just crazy to think about.
it's a couple clicks, or even just a manifest.
Or a manifest, yeah.
Yeah, to configure that route. So, and that's the one thing that I just love about Kubernetes is the API driven approach to infrastructure, and it's pretty amazing. So, I know we only have just a few minutes left. So let's just recap what we did today. We did a lot. Created a virtual network, created a subnet, deployed our AKS cluster into that subnet using Azure CNI. And then we put a little, we deployed Azure OpenAI, and then we put a little firewall around our Azure OpenAI service. That enables us to secure all that incoming traffic to ensure that it only comes from one particular destination that we are aware of, which is the AKS subnet. And then we deployed the Azure Application Gateway for Containers, which again is in preview, but I highly suggest you go test it out because it's pretty amazing. And not only the service itself, but just working with the Gateway API is such a pleasure. So that's kind of what we did there. And I would suggest that if you want to see all this stuff end to end, I mean, obviously you can do the step by step, but I do have a Terraform template. I'm a bit of a Terraform junkie. I think you are too, Josh.
I am. Yeah.
So I have a Terraform script that'll actually just provision all this stuff end to end using a single Terraform apply command. So if you just want to see it up and running, see it in action, and then just play with it from there, and not have to go through all the Azure CLI steps, feel free. The link should be in the chat, or there we go. I see it on the bottom there. Feel free to go check that out. And I think that's all we have. Yeah. This has been a blast. It's been super fun. Fun for me. I don't know about you, Josh, but
Likewise. I've enjoyed these live streams.
Yeah. I would say if you missed any of the episodes, go ahead and head on over to this URL, and the recording should be there. If you have any questions along the way, feel free to reach out. You can catch me on Twitter or LinkedIn or any of the other social channels. And
Handles in
Yeah,
the name, I believe, right there on the screen.
that's
Right.
right.
That's
That's
same for
right.
me. I'm at Josh Stephanie on Twitter, X, whatever you want to call it. And same thing on LinkedIn. But
Yeah, yeah.
yeah.
Cool. So this has been super fun, and I hope you all enjoyed it. And yeah, let us know how it works out for you. And can't wait to see what you build next. So cool.
All right. Well, thank you all for watching. This has been a fantastic time.
Thank you.